because it turns out a mountain bike is a bike. It's a bicycle, and so we'll see this later on in the term that I can treat that mountain bike as if it was a bicycle. Because mountain bike extends bicycle, so it has everything a bicycle has plus more. So if I have a mountain bike object, I can treat it as a bicycle. I'm guaranteed that everything bicycly is there. Because mountain bike only added, cannot take away.
That makes sense. So if you're extending another class, then unless you have everything that the bike class requires on top of whatever your extended class requires, you can't create that object. So if a bike requires cadence, speed, and gear for an object, you couldn't possibly create a mountain bike that didn't have those things.
Right.
Okay.
Unless mountain bike didn't extend.
Right, okay.
Right.
But if there was a constructor that didn't take arguments?
Well, then you have, then you wouldn't need super.
Gotcha.
But you would still have the same situation where mountain bike was an extension an extension of bicycle.
Okay.
Okay, so, yeah.
So this code then that you've written, we could say bike B is equal to NB here?
Yeah. Yeah.
It would only expose the bike fields.
Right. I could also now have bicycle equals MB. And that's legitimate.
Even though bicycle doesn't have as many fields.
Right. Well, what that means though is if I said, okay, bike dot set height, which set height is a mountain bike method, the compiler will complain and say, bicycles don't have a set height. What are you talking about?
Got it. Okay. Cool.
So you're saying that statement, the bicycle B equals MB is legal, but it's not right, like, because you're still
it's
missing.
okay to do. It's legal and it's okay to do. For example, suppose I have it makes more sense in a collection, but suppose I have a whole bunch of mountain bikes and road bikes and whatever other kind of bike you want to think of. And I just have them all in a different collection. And I want to, for all of them, I want to apply the brakes. Since they all are derived from bicycle, I could just have a loop, or I'll leave the details of that for later, and then for each bike, I'll call it B, apply brake. And it doesn't matter if it's a mountain bike, or a road bike, or a whatever bike, they all have apply brake because they all derive from bicycle, so it's always a valid thing that I can do on that object.
Okay, that makes sense. And then the only time you'd get with the problem would be the height, because it doesn't, bicycle doesn't have the height.
And then the compiler will actually tell you about that. Say B is a bicycle, so you don't have set height.
That makes sense.
Okay. That was about 5 times as much material as they intended for this slide, but that's okay. Because this is meant for beginners. You guys aren't beginners. All right, next is declaring classes, which we've seen already. Class, my class, and all the stuff inside it. And then we have extends. Later, we're going to learn about interfaces, which will be this extra keyword, but we'll ignore it for now. Okay. Member variables, we have the access, the type, and the name. In the case in bicycle, they made all 3 of them public. Private is much preferred. In fact, they redid it here. And then they also added getters. Get gear, get speed, and get cadence. And that's a much better, much safer way of doing this. Okay, so we already seen the methods. I don't need to go through that so much more. overloading. Okay. Overloading a method is something we can do. We can do it in C++ too, but in Java. And what it means is you have the same name but different arguments. So here they made up a class called Data Artist. I don't even know what it's supposed to do, but it has draw, 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 draw. It has 4 different draw methods. Now what's the difference between these?
They have different parameters.
They have different. What's the same in all of these?
The name.
Return type and name. So they both have. All 4 of them have the same return type and all the same name. They actually all have the same access level too, but that is not required. You can have different. You can have. These are all public, but there's actually 4 access levels in Java, and these can all have different access levels. But what has to be the same is the return type and the name. Now the reason we do this is, in this case, draw a string might have one behavior, while draw an integer, has a different behavior, and the same with these other things. So overloading is a very nice thing that we can do, because you can use the same function or same method, but with different parameters. This last one is interesting because it shows that it's not just a different type and the same number. This has 2 parameters, while the others have 1, and that's perfectly fine to do. You could even have another draw with no parameters.
So any difference in the parameters means you can overload.
Any difference in parameters means it is an overload.
Yeah.
Yeah.
What's the reasoning in needing all the return text to be the exact same?
It has to do with the way the language is parsed, which is if you allow for having different return types, then in this case they're all void. But if let's say this returned a string and this returned an int, then when I have a draw method somewhere, if I have code that says x equals draw and then something else, when I'm parsing this, I can't know that this is valid until I look at what the type of this argument is, and to see what the return type would be to see if this is this. Now, in primitive types, it's not something we can kind of work out, but if we did this kind of thing where I've got a hierarchy, an inheritance hierarchy, where I have to actually go figure out the whole inheritance tree here and match it against the inheritance tree here, it gets really complicated.
What if you nested them?
Nested them, what do you mean?
So it relied on the output of another overload, so you didn't even know what the type was?
Yeah, then you might, yeah, that's another good point. So what he said is, what if I did this? So in this fake world where draw has different return types, what if I did draw x? And so then I have to unwrap it even more. There are some languages that allow overloading on return types. I don't remember any of them right now, but it's strange. And it just makes it really hard to compile. So overloading, maybe it sounds fancy and maybe it looks fancy, but it's an extremely natural way to do things, and it doesn't take very long at all, and you're very used to it. And then when you go back to a language that does not support it, like C, you hate it. Because back in the bad old days, I don't know if the newer versions of C support it. I don't know. I don't think so. But you would have to have draw string, draw int, draw double, draw int and double. You'd have to have a separate function for every type of thing that you want to pass in, which becomes a maintenance nightmare, really. Okay. Constructors, we walked through that, and we walked through the super part of constructors. Something that we can do in Java, I never do this, or very rarely do I do this, but I'll point out anyway, you can have an arbitrary number of arguments to a function. And you do it like this. So this, the idea is to make a polygon. So you have a set of points that are passed in, and then each of those points represents a corner in the polygon. What it turns out that with this syntax, point, dot, 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 corners, it seems to convert it into an array of these items. And then you can treat it as an array down here. It's really a corner case. I don't recommend doing this unless you absolutely need it. There are some situations where it is very handy, but most of the time it's not. And unfortunately, I see people using this, actually, I would say abusing this, where they, for some reason, don't want to type out, maybe they've got 4 or 5 parameters and they're all integers or all strings. They just don't want to type them all out, and so they use this instead, which is not
very readable.
It's not very readable. Also, what if the person calling the function was supposed to pass 4 of them, but they passed 6? You wouldn't know, and the compiler would not tell you that was wrong. So you would have mistakes in your code that the compiler wasn't catching.
So does the amount of dots say how many of
No.
those things get? It's just 3 dots, and it
3
could
dots,
be
and
whatever.
it's any number.
Oh, geez. Okay.
Because
So-
do all the arguments have to have the same type?
Yeah.
This is an array of points called corners, right?
Mhm.
Okay.
So, would it compile if you were expecting 6 and they entered 4 then?
No, there's no way I'm doing this to say I want 6.
Okay.
So it would compile, and then when you tried to access elements 5 and 4 and 5 out of that 6-element array, if you only pass 4, then those would be null and you would crash.
Is there a way to do it with a loop, like a for each of whatever is passed in?
Got the length. You probably
Using-
would. Yeah, you could, because you always can get the length. It shows it there that you get the
Mhm.
length. So yeah, you can do it for them. I don't know why people do it this way. If I have a variable number of arguments that need to go into something, well, first of all, I usually think I did something wrong because I should know what I'm getting. But if I have if I need to pass in a bunch of things, I just pass in an array, or I pass in some other collection of these items. I don't rely on the syntax in the language to try and fake it for me. This is where they're saying that you see it, is things like printf. And what happens here is you have this gives you an example. I have a string as my first argument, which has a bunch of format specifiers, %s, %d, %s, and then each of these matches to an argument.
Mm.
Now the thing is I could just as easily, instead of doing this, I could just pass in an array of objects
Yeah.
and handle it that way. So. Okay. This is stuff we covered last week, so let's get past it and on to objects. Okay.